Hello, and thanks for joining me today. So this is the final video we have on the RHCSA hands-on lab, and this topic is manage containers. We've seen different topics, manage security, users and groups, basic networking from part 1 to 9. So this would be part 10 in our RHCSA hands-on lab, which is the final one. I have a VM which is running already, and I'll just SSH into the VM. It's on UTM, and we've got questions we're going to consider for this lab. If you're new to the channel, please subscribe, turn on the notification, give a thumbs up, do share with anyone that's going to benefit from this. Let's get started. So let's see if Podman is installed. Systemctl status Podman. Yes, Podman is installed and running. That's good. So the task is for us to do this: run the container with as this user. Since the container is expected to start, that's one of the expectation for this task, is that when the user logs in, user Haruna, if I log in, that container should start at system reboot or user login. It should start the container. So you have to enable a linger for that user. So loginctl, that's why as root, that's why I logged in, I searched as root to do this. So loginctl enable linger for particular user Haruna. Yes, I've done that. So that's the only task we need to do as root. So you go out, exit, and now we SSH as that user to do what we've been asked to do. 192.168.70.12. Hit enter. Password is password. You'll be given, well, all this on the exam. So we're in now. Podman is running. So let's create the image. Let's build the image from here. But before we do that, let's check if there are any images. Podman image list. Hit enter. There's an image from registry.access.redhat.com, the UBI 9 image, but that's not what we are going to use. But just to check to be sure what's available there. So Podman image list, and let's check if there's any containers running. Podman PS, you can see there's nothing running. Podman PS-A, if there's any other containers that are stopped but they're there, no. So with that we can create that image. So Podman image image build -t, we are saying what's the tag for that image. That's the name. So the tag from, let's come back to this so the tag, what we want is it says named, it's named web image, so web underscore image, so it's web image. So we want to build an image with the tag -t web, the name is web image, and then the file we want to use for that is the container file we want to use is located here at http colon, so we specify repo.rhcsa.home/containers container file. Just keep in mind that you will be given all this information on your exam. So you will have the URL, you have the username and the password to log in to the container registry to do to create the image. So Podman image build, so -t, I want to build this image, this is the tag, that's the name, and then the context, I want to do it here. So hit enter. So you can see it's pulling the data from the container image, it's building the image from the container file, it's building the image. It's done actually. So you can see the important information here is that successfully tagged this what we have now as the tag of our container. So unlike before, now if we do Podman image list, we should see our new image, the image we just created. That's it. If you're on the exam and you are asked to log into the container registry, you just use Podman login. Podman login you can specify the registry. So in the example could be maybe example.redhat.com or anything. That would be provided to you. So registry.access.redhat.com. I am showing you this step just so you know you have a different registry provided. You just do Podman login, and a username and password will be provided for you. So, but let me use Haruna Adoga. That's my username, my password, and then you see login successfully. Then you can do what I just did with creating the image from the particular registry. So yours on the exam could be this example.redhat.com or something. So I just hope you this makes sense to you. So we have created the image. Just to add, if creating the image and logging it to registry or specifying what container file to use, if that's not clear, please drop a comment, ask anything you want to ask. I would explain. So Podman, again, Podman image list, we have our image. So what's the next task? We are done with 1. So 2, which is the final one, is for us to create deploy Haruna web container. So now we have an image. We're going to use that to build a container, so to run a container. So the syntax Podman. Another point, if you're already used to Docker, because I used Docker, and when I had to start learning Podman, it's technically the same thing. It's same everything. Docker PS, Docker run, Docker image list, Docker exec. It's same. Just replace Docker with Podman and you're good in most cases, at least the things I've tried so far. So Podman run, I want to run a container, right? The container I want to run detached, interactive, and I want that to be the name. I want to call it Haruna web _web, and I want to map the port. Let's start with port 80, port 8000 on the host that's on this VM to port 80 on the remote on the container. So I want to do that, and I also want to map, what else? I want to map a volume which is in opt this directory, user files. I want to map that, so colon, I want to map that to a directory called /opt/user files inside the container. But because of SE Linux context, I need to specify that the container context should be used for that file, just so it can be accessible. So I want to create this container. These are the details. And I want to use the image. You can see from Podman image list, the image we just created. I want to use web image. You can specify the whole path of the and the tag if you want, but this, since we already know we created the image, we know the name. It is web image. That's the image I want to use. So Podman run -dit --name. I want to call it Haruna web, Haruna _web. I want to map the port 8000 from the host to port 80 inside the container -v. I want to map the volume /opt user _files colon. I want to do that with opt /user files inside the from the container, and I want that to use container file context for SE Linux. And the image I want to use is web image. If I hit enter, fingers crossed, let's see. Yes, that's good. We have created our container. So now if we do, unlike before, if we do podman ps, we should see a container running. So we have a container. The name of the container that is running now is Haruna web, and it's been up 7 seconds. We just created that, and then this is the image it's using, right? The image from, the image we just created, web image, and this is the container ID. So that's us. We've created the container. We've mapped. So it says files should be accessible. So what does this mean? First, we just created the container. We have to make it a systemd. We have to generate a systemd file for this container. But before we do that, we can check if we've met this criteria of files should be accessible. Let me get into the container itself. Now the container is running within on the VM, but we are on the VM just now. So let me get into the container itself. We can use Podman exec interactive on to run Haruna_web. That's the name of the container, and I want the shell beam bash shell. Hit enter. That's it. You can see the prompt has changed from Haruna at node 2 to root at the container ID. I am inside the container now. Okay, that's good. Since I'm inside the container, I should be able to go to opt. Inside the container should be user files. Yes, user files. So that's me inside the container trying to get here, which is mapped, the storage that has been mapped, or the drive directory that has been mapped from the container, from the host. So if I hit enter, I am there. pwd, you can see I'm in opt user files. So if I hit ls, these files, guest, host, new guest.txt, these files are on the host and they are accessible from the container. But let's create ours. So let's create a new file, or let's echo RHCSA and put it in a new file called RHCSA.txt. Now we are creating this file inside the container, right? So if I hit enter and do an ls, we can see the file, it's there, and we don't need to cut, we just echo content into it. So now if we go on the host, if I exit from the container, I'm back on the VM, and I should be able to see that file, opt user_files. I should be able to see RHCSA here. Perfect. And if I cut RHCSA, you can see it says RHCSA. Awesome. So that's it means our container is okay just now. But we still need to, let me go out of the opt directory. Let me go home to Haruna's home directory. We still need to create this as a system D file. It says system D rootless container. So it means already, since we are doing this as a user, it is a rootless container, right? So we need to create a system D file. So we do that while the container is still running. Podman. So let's say Podman PS. We see the container is running Haruna_web. It's there. It's running. So let's do Podman generate, right? Podman generate system D. Podman generate system D. So new files. So just get the files from the container. We are going to specify, and the name I want to use the exact name of your container. There are other syntax you can use. You can do check with Podman generate if you want to. That's if you cannot recall, but specify the name of the container, exact name of the container that is running. Use that to create the system. Use the files there to create the system D file. So I want to generate a system D file. This is the name, files. And remember, if you do this, it's going to create that in the current working directory, right? It's going to do that in the current working directory for you. So it's going to keep it in my home directory. But it needs to run in a particular location. Run from a particular location, .config/systemd/user, which we're going to create that directory. But just see, let's generate first. Hit, I think it's that all. I think that's all. We want to generate, and this is the name. Hit enter. Yes, that's all. Ignore this warning deprecated command. There is no error. It's generated. How do you know it's generated? Do an ls where you run the where you run the command. You can see it's there. Container Haruna_web.service. So now this is a system D service, right? With this done, we need that directory mkdir-p. Why I am using -p, it's I want to create a directory, a subdirectory, a directory in a directory. So -p, I want that to be in home.config is already there, but there is a directory system D user. So this directory, if I hit enter, with this directory, I can move this file, this container file, this systemd file, because it's a rootless container. It's a user space container. It's not a container created by root or someone with sudo privileges that you put in the global systemd file location, if that makes sense. This for a user, so this in the user's home directory. So move this file to the location we just created, systemd user. So move it, it's there, it should be there now. So let's go into that place, config systemd user. We're in ls and that file is there. So our systemd file is there. Note that our container is still running while we do all this, right? Our container is still running. But now, since we have created this file, we have created this systemd, the service, right? We can stop our container, remove the container, and enable the systemd file, the systemd service, start and stop. It's just like another service now. It's just like a service. The way we do systemctl start HTTP, we can do that on this container. The way we do, any service, So systemd is going to take care of this for us. So let's stop this container, right? Podman Podman stop. What do I want to stop? I want to stop a container called Haruna_web. Hit enter. It stopped. Podman ps. Now you would see that it is not there. Yes, but if you do podman ps-a, it's not running. It stopped, but it's not running. So it's going to show you everything, even with containers that are stopped. But we want to remove this completely. Podman rm. I want to remove Haruna_web. And if we do podman ps-a, it should be empty. So nothing. It's assumed that we don't have any container running, because our goal is to have that as a systemd service, which we've already created that file. But just a few things to do, just very few. We need to reload systemd. So that's a daemon reload. We need to reload that just so it can register the new systemd service we have. So systemctl. But before then, yeah, we already have that service, right? So systemctl --user. --user here is because this is a rootless command. This is a rootless systemd service, where we are not doing this as a global as root or someone with sudo privileges. So systemctl --user daemon daemon reload. Yes, and I did enable login, enable-linger. I did enable, yes, linger as the root user, just so this service can start when with user login. We can still do that, loginctl enable-linger, while logging as that user, but do it as root anyways. I'm just trying to make sure I cover everything, because the container task, to be honest with you, is a bit tricky. If you don't capture everything, if you try to start the container, it tells you that the systemd file is not found anyways. I've run into this a couple of times, but I think we are fine now. So now we have the systemd file. We have reloaded the daemon, that's systemctl daemon reload. Now what we need to do is to start it. It's just another service. So systemctl --user. Remember, rootless container, we are doing this systemctl, and we want that to be systemctl enable, right? We want to enable now. What do we want to enable? We want to enable this file. We don't have any container running now, but since it's a systemd file, we want to enable this file. So I'm using a -- now just so it enables and then starts as well. Hit enter. Yes, awesome. It looks like we did the right thing. So it's been created. the symlink created, it's been enabled anyway. So if we do systemctl -- user and we say status, we want the status of container haruna_web.service, right? Enter, you can see it's just another systemd service. It's just like systemctl status HTTP or SSH or NFS, whatever it is that you're checking. Yes, it's running. And then if because it's that particular image is for a web server, but the image doesn't matter because you could be given any image on your exam, so it doesn't matter. Just know how to do it, how to create container, how to generate the systemd file, how to run it as a systemd service. Now, if we do a Podman ps, hit enter, you can see that the container is running. It's Haruna Web. And remember, we did not use Podman run -- this to specify the name, map volumes, everything. We just used systemd. We created a systemd service, and we can now stop the container. You can shut down your system, log in. Each time you log in, it will come up with user login, will come up with this container. You can stop it anytime, and it's this got a very good use case even in production environments. So Podman, I think that's it essentially. So we can do systemctl user, and we can stop actually container.service, and it is going to stop this just like a service, any other systemd service, So we can check again what's the status of container.service. You can see that if we inactive, so dead, it's dead, so it's inactive here. But we did enable this to start anytime -- when I did enable -- now. So but it stopped. So and now we can do Podman ps anyways, just to be sure. Podman ps, hit enter, it's not there, right? And that's it. That's the end of this task. So that's the end of the series completely, the RHCSA hands-on series. We started with the first exam objective. My approach is different. What I mean by different, because I did all the questions we've answered in the series from part 1 to part 10 is based on the exam objectives, not just random stuff. So if you're preparing for the RHCSA, or just someone who is into just Linux in general, cloud, DevOps, security, containers, Kubernetes stuff, and you're trying to learn all this, you can start from the first video, part 1, and go through all. I've covered all this. We've done this up till now, manage containers, and that's the final one, which we just did. So I would like to thank you for watching, and if you have not subscribed, do subscribe. There will be more videos on Linux in general, container stuff, security, cloud as well, and I would do more RHCSA specific exams videos as well, just so I help people that are preparing better. Things like maybe the mistakes that most people do, like the most difficult tasks, things like that. So that's also going to come up. Thank you for watching, and I'll see you in the next one.